Hey class, now that we are experts on factoring quadratics, we are going to use factoring to solve quadratic equations. So remember, to solve, we want to find the value of the variable that makes the equation true. So we're going to use factoring and solving. Let's start with a little review. We're going to review the greatest common factor. So this is something that I didn't stress enough in the first two lessons, but you need to always factor out the greatest common factor first. That should be your first step. If there's a greatest common factor, you should take it out first. Remember, you find that by thinking, what can I divide both of or all of the terms by? So in the first example, I can divide them both by 5, and then I have an x to the 5th and an x cubed. So I can divide them both by x cubed. That's like the largest one they both share. When you factor that, what you can divide by goes out in front, and so it's times, and then you divide in what's left. So here the 5's would cancel, and I'd be left with an x squared, because I had 5 x's and I took 3 out front. And then 10 divided by 5 is 2, and I took a x cubed out of an x cubed, so no x's left. So then that's how that would look when you're done. And x squared plus 2 doesn't factor any further because it's nothing multiplies to 2 and adds up to 0 in the middle. Oh, excuse me, I'm tired. It's late. You can see it's 10:30 when I'm making this video almost. Okay, the next one. All of these are even, so I can divide them all by 2. And then they all at least share an x. So that 2x will go out front. And then dividing 4 divided by 2 is 2. X cubed, take away an x, is x squared left. And then negative 2 divided by 2 is just negative 1. X squared divided by x would be x. And then negative 6x divided by 2x just leaves me with a negative 3. Can I factor that any further? So I can throw it in my box and just give it a try here. I got a 2x squared and a negative 3. 2 times negative 3 is negative 6. I would need something that multiplies to negative 6 but adds up to negative 1x in the middle. I can make that with negative 3 times 2. So it would be negative 3x and positive 2x. So then what they have in common here, 2x and 3x have just an x in common, but 2x and 2x squared have a 2x in common, and x times 2x is 2x squared. And then the last row, they both have a negative 3 in common, and you know, x times negative 3 does give me negative 3x, so that's correct there. And then the bottom row, they just have a 1 in common. They have nothing in common, so just a 1. And that makes sense because 2x times 1 is 2x, so that works. And then 1 times negative 3 is negative 3, so that works. So this did factor more. The 2x stays out front, and then my factors inside become 2x minus 3 times the quantity of x plus 1. All right. We're going to show you how to solve that in just a minute. This is just an expression, so we're just simplifying it. Notice that there is no equation because there's no equal to sign. So these are just expressions that we're factoring. We talked about special patterns when we talked on the very first day, and we talked difference of perfect squares, which was a squared minus b squared, and we talked about how that factors to a plus b and a minus b. Well, this is another type of special pattern, and you can factor them with the box just like I've been teaching you, but if you can see that it's a special pattern, then you can save a little time. So both the terms on the first and last term have to be perfect squares. So like this one, 4 is 2 and 2, and 9 is 3 and 3. And then if you multiply, 2 times 3, you get 12, or 2 times 3, you get 6, and in the middle you have 12, so you have double it. Then it's a perfect square trinomial. So basically, a perfect square trinomial is a squared. It can be plus or minus it'll be 2 of the a b's together, and then plus b squared. So it can be either plus or minus for the second one. But basically, the middle term is double the product of the a and the b. Then it factors to this. It depends, it will be either a plus b and a plus b, or a plus b squared. That's if it adds up to a positive in the middle. Or it'll factor to a minus b times a minus b. That's if it, or you can write that as a minus b squared. That's if it adds up to a negative in the middle. So this one adds up to negative 12 in the middle. So our a is going to be the 2z, and then it's going to be minus 3. And then we're going to have another 2z minus 3. So you can see how this works, because you're going to get, a 4z squared there, and you're going to get 9 on the end. And then in the middle, we get a, 2z, negative 6z, and then a negative 6z here. So we get all of our terms there. So this one you can rewrite as 2z minus 3 squared. So 2 of those exact copies. That one would work just fine in the box. The numbers are small enough. But sometimes perfect square numbers are rather large, like this one. So multiplying using the box, you would have had to done 36 times 25, which is a very large number, and then 900, that adds up to 60, and so it might be harder to work with. So if you can recognize that these are perfect squares, then you can try this. So it'd be 6w, it adds up to positive, so it'd be plus 5, and 6w plus 5. And then just check to make sure it works. So I know that I'm going to get, the 36w squared from the first two terms, and I'm going to get 25 on the end. So really you're just checking the middle, and you're going to have 6w times 5 is 30w, and then 5 times 6w is 30w. So you would get the 60w in the middle. So you can write this one, since they're both the same, it's the same thing as 6w plus 5 and then squared. All right. So zero product property is going to come to this. The zero product property says that anything times 0 is 0. Basically, if you have a times b equals 0, then either a equals 0 or b equals 0. Okay? That's what the zero product property tells me. So step 1, we have an equation now. So it's different than an expression because we have an equal to sign. Step 1 is to factor. Well, right away I notice that I can divide all of this by 2 and get rid of that 2. So I got x cubed minus 9x equals 0. Then taking out a greatest common factor, and I can take out, and I can divide this one by an x, and I can divide this one by an x. So I'm going to take that x out front, and that leaves me with an x squared minus 9. Then I can keep factoring that. I have an x out front, and I know that x squared minus 9 is difference of perfect squares because 9 is a perfect square. So it would be x plus 3 and x minus 3 equals 0. So now we have an a times a b times a c equals 0. So zero product property says, well, one of these has to be 0. So either a, so x equals 0, or x plus 3 equals 0, or x minus 3 equals 0. So anything times 0 is 0. So if any of these factors equals 0, then the whole thing would equal 0. So that gives me 3 answers. Well, x equals 0 is one choice. If x plus 3 equals 0, then x would equal negative 3, solving that one for x. And if x minus 3 was equal to 0, adding 3 to both, x equals 3. So I have 3 answers there. X equals 3, negative 3, and 0. And one thing to note is the degree of the polynomial does tell you how many answers you'll have. Sometimes you have a double root, which means you get the same answer twice. But if it's a cubed, you should get 3 answers. Squared, you should get 2 answers. If it's just x, you should get 1 answer. So the degree tells you how many answers you're looking for. All right. 3x squared minus 15 equals 0. So right away I notice I can take and divide everything by 3. If I was factoring it, I want to make sure to put the 3 in my answer. But when I'm solving, I can divide by 3 and just get rid of it. So I get x squared minus 5x equals 0. Then I can take out an x. I don't want to divide both sides of the equation by the x because I need x as one of my solutions. So I take that x out front, and then I'm left with an x minus 5 equals 0. So this is an a times a b equals 0. So either a equals 0, so x equals 0 is one answer, or x minus 5 equals 0, which means that x equals 5. So either of those answers would be a solution to this equation, 0 and 5. All right, I'm going to do the second example on this one. So in order to use the zero product property, your equation has to start out equal to 0. So the first thing I'll need to do in this example is move the 30 over. Now these are all unlike terms, so I'm just going to tack the 30 onto the end. I want it in standard form, which means I go from highest exponent to lowest, so from x squared down to the constant, in that order. This is just an x squared term, so I know that my factors are going to be x times x. So all I have to do is find two numbers that multiply to 30 but add up to 11, which would be 5 and 6. Positive 30, positive 11, so both positive factors. So this is like an a, and this is my b. And if I have a times b equals 0, well then either a was 0 or b was 0. So either x plus 6 equals 0 or x plus 5 equals 0, which means my two answers would be x equals negative 6 and x equals negative 5. All right. I'm going to do this example, and that'll be it for this video anyway. All right, so first, to use zero product property, we have to be equal to 0. For factoring, I want my leading coefficient to be positive, so I'm going to move to whatever side has more x squareds. So the 2x squared's on the left, so I'm going to move the negative 4x by adding it. I have a like term on the left of a 3x, so I'm going to add 4x to that 3x. Then I have a positive 10, and I'm going to subtract it, and I'm going to combine it with the other constant on the left side, which is the negative 5. So that's going to leave me with a 2x squared, 3x plus 4x will be 7x, and then negative 5 minus 10 is negative 15. Over here, I get 0. So now I can start factoring. Notice if I had a common factor of like 2 or 3, I'd divide everything out by that first, but I do not. So I can use my box. I want 2x squared here and negative 15 here. Then I multiply the 2 times the negative 15 and get negative 30. Then I need to find numbers that multiply to negative 30 but add up to my middle term, which was 7. So negative 30, 1 and 30 doesn't work, 2 and 15 doesn't work, negative 3 and 10 does work. Positive 7, so negative 3, x positive 10x. Then finding the greatest common factors on the outside. So 2x and 3 have just an x in common. 10 and 2 have a 2x in common. And 2x times x is 2x squared, so we're good there. And then x times negative 3 would be negative 3x, and 2x times 5 would give me the 10. And then just double check, 5 times negative 3 is negative 15, so that works. So then I factor this is 2x minus 3 times x plus 5 equals 0. So this is my a times my b equals 0. So either a is 0 or b is 0. So that means either 2x minus 3 equals 0 or x plus 5 equals 0. Well, if x plus 5 equals 0, then x has to be negative 5. That one's easy to solve. This one I have to add 3, and I'm going to end up getting a fractional answer because 2x equals 3 divided by 2, and x equals 3/2. All right. For the sake of time here, I think I'm going to be done with this video. Oh, let's see. I'll do one more. All right, this one has a common factor. I can divide them all by 4 and x. So you could just divide all by 4 and get rid of the 4, or you can leave the 4 out front. It really doesn't matter. When you solve, you're going to get the same answer. That x is going to be 0, but the x has to be out front. So then I get 2x squared plus 3x minus 2 is left equals 0. Factoring the inside more, I'm going to get 2x squared, negative 2, first and last term. Multiply those together is negative 4. I have to add up to 3x in the middle. So it'd be negative 1 and positive 4. Negative 1x and positive 4x. Finding the greatest common factor of each row and column. This one has just an x in common. This column here, the first one has a 2x, then x times negative 1 and 2x times 2. So this will factor to 4x, and then 2x minus 1, and then x plus 2, all equals 0. So this time we have an a times a b times a c equals 0. But if a was 0, or b has to be 0, or c has to be 0. So either 4x equals 0, we'll divide that by 4. You're getting rid of that 4 either way. So you could either get rid of the 4 at the beginning, divide everything by 4, or get rid of it here. But you need this x. That's your third answer. It's an x cubed, so you get 3 answers. Then 2x minus 1 equals 0, so you're going to get a fraction here, 2x equals 1, or x equals 1/2. And then x plus 2 equals 0, so x equals negative 2. So 3 answers for that one. All right,